Okay, let's start. Let's do the worksheet problems in section 1.8. 1. Which of the following is the standard form of square root minus 11 squared minus square root 100 minus negative 100 plus cube root of negative 8? So let's do it one by one. So the first thing is minus 11, okay, negative 11 squared. What is this equal to? Now the rule for this one is no matter what x is, so the square root of x squared is equal to the absolute value of x. So this is true for any x, for any x. So it means x can be negative as well. So then I use this property here. So it will be the absolute value of minus 11, so which is equal to plus 11. Now when it comes to here, the square root of negative 100, so the rule, okay, the first thing you have to pay attention to this, it's negative. So negative, the square root of a negative number is just a complex number. So you have to end up with something with I here. There will be I. Something with I plus something. Okay, this if you have negative and square root, so this will have I. So let's do it. The formula here is the square root 100 times I. So it's 10I. So let me remind you the rule here. The rule is if you have a negative square root of negative a, it's not a real number, so a is positive here. So it will be square root a times I. So this is the rule here. Now the other thing is this cube root of negative 8. So this negative doesn't make a problem here because this is odd. So, okay, remember this, if the root is odd, the index is odd, so it accepts also negative numbers, so the answer will be a real number, so no complex number. So we do this. Okay, you can write this one as the cube of negative 2, so it will be negative 2. So you remember this one. I'm going to show it to you. Is equal to x if n is odd. So, and here x can be also negative. X can be negative if n is odd, okay? So I'm using them, so if you put them together, like this one will be 11, and this one will be minus 10i, and this one will be negative 2. So when you add them, you will get 9 minus 10i. So be careful about this, okay? These are the rule, and if you have a negative number and the square root here, there should be always I, and if there is the 3 odd number here, we accept, okay, it accepts negative number, and the answer will be a negative number, a real number, not I. Let's solve this exercise. We will do a product here. Okay, there are two ways of doing it. Like the first way is this one. First way, you can do the straight multiplication or straight product rules, distribution property of multiplication. Okay, square root 2 times square root 2, and then square root 2 times this. So we have like plus here. So when you multiply, you get minus. Square root 2 times square root 3i. So just write them as multiplication, and these two will make square root 3i times square root 2, and then this will make minus square root 3i times square root 3i. So then this will be 2, and this will be square root 6i. And here again, you can move I to back. So you will get square root 6i. And here this will be square root 3, square root 3, 3, I times I squared. So you got 2 minus, okay, they are like terms, they are similar terms. This one is this plus, and the other is negative, so you can write here 0. And then, so they will cancel each other. 3 minus I, 2 minus 3i squared is 2 minus 3 I squared. Y squared is minus 1. So we'll end up with 3, 2 plus 3, which is 5. Okay, then there's a second way of doing this. Second way is a kind of easier, but you have to know some special product rule. The special product rule is this: a plus b times a minus b. So the second way is this. Okay, and you can see this one is, this product is like the product of a sum and difference. So it's like a plus b times a minus b, and the rule is a squared minus b squared. So this is a special product rule. So if you do such thing like a squared square root 2 squared, and then minus square root 3i squared. So if you write this answer here, it will be 2 minus, okay, 3 times I squared. So I squared, okay, always don't forget this, I squared is always minus 1. So we put this 2 minus 3, so it will be 5. And there's a second method. Yeah. So in this exercise, we will find the imaginary part of this complex number. Now, imaginary part is this one here. If you write a complex number in standard form, this part is called the real part, and this part is called the imaginary part. Okay. Now we want to write 2 minus I over 1 plus I as a plus bi. So then we will find this one. What is b? You know, to change a complex fraction into a standard form, you have to multiply it, okay, with a fraction whose denominator is the conjugate of this one, and the, okay, and numerator is the same. So this mathematically, this whole thing is 1, so it doesn't change anything, but so you have to multiply with the conjugate. So, and a reminder, so if it is minus, it will be plus. Okay, so minus to plus and plus to minus. And let's do it. We can do this multiplication here. So you can do the distribution rule here. So it will be 2 minus 2i, and then minus I, and then minus minus it will be plus, and then I squared divided by, then you can use the previous rule, 1 plus I times 1 minus I, so it will be 1 squared minus I squared. So I'm using here I, a minus b times a plus b rule. Okay, don't forget this one. Now, after doing this, you will have 2 minus 3i minus 1. So don't forget this, this becomes minus 1. Divided by 1 minus 1. You see it? So it will be, when you combine the real parts with reals and the imaginary with the imaginary units, so you end up with this. So then you separate them, 1 over 2 minus 3 over 2i. So the what's the imaginary part then? The imaginary part turns out to be minus 3 over, this is I here, minus 3 over 2. So the answer is C. Which of the following is equal to this one? It's a straightforward question. So you just use the distribution property, and maybe you can use special product rule. Here for this one, I will use straightforward distribution 2i times 3i squared. Okay, don't forget this is I times I squared. And for this one, I can use the special product rule, 1 squared minus I squared. So I mean, again, I'm telling you this a plus b times a minus b type, so it's equal to a squared plus b squared. So if you have minus here, okay, please don't forget the parentheses. The parentheses are very important. Parentheses are very important. Now 2i minus 3 times minus I, and then 1 minus 1. Okay, when substituting I squared, use parentheses also. So 2i plus 3 minus 2. So this will give us 2i plus 3 minus 2. And this will give us 2i plus 1. Or you can write it as 1 plus 2i. So the answer is C again. Okay, let's z sub 1 is equal to negative 2 plus 3i, and z sub 2 is equal to 2 minus I. Let's find the real part of this problem. So the real part, as I said, it will be a plus bi. We will write it this type, and we will find this part here, the real part. Now first, what is when we substitute z of 2, z sub 2 squared, okay, it will be 1 over z sub 2 is 2 minus I squared. So we want to write this one as a plus bi. So then we will check bi. Okay, then now the first thing is it's better to take care of this one first. 2 minus I squared is what? You can use special product formulas, or you can do this way. So it's not a big job, just you can do distribution. You'll get 4 minus 2i, and there's minus 2i, and then this one here plus I squared. And when you do this calculation, you will get 4 minus 4i minus 1. Okay, this one here is minus 1. And you will, you will get this one as 3 minus 4i. So this turns out to be this fraction turns out to be 1 over 3 minus 4i. So it's coming from here. And now our goal is to write this one in this form again, so a plus bi. So we want to convert this fraction to that form. So how can you write it? The idea is, of course, using the conjugate. So you can use it. It's no, use the conjugate. The conjugate is, 3 plus 4i and 3 plus 4i. So when you use this product, you'll get 3 squared minus 16i squared. Here's 3 plus 4i, and this is 3 plus 4i divided by 3 squared 9 minus 16 times minus 1, which is automatically 3 plus 4i divided by 25. And then you can separate them. So what is the real part here? The real part will be this. So the real part of 1 over z2, z sub 2 squared is 3 3/25. Okay, this is the second part of the same exercise. Okay, Z sub 1 is this, Z sub 2 is this. Perform the indicated operations and write the answer in standard form. The standard form is like A plus BI type. Okay, now we have to write it this way. So it's asking 2Z sub 1 plus Z sub 2 divided by Z1, Z sub 1 minus Z sub 2. And let's substitute them. So we can write 2 times -2 plus 3I plus, okay, if there's plus here, so you don't put them in parentheses, like you don't have to do it. I mean, you can do it, you can do this way, but since there's a addition here, you can remove them. Okay, the important part is here is when it's negative here, so when it's a minus sign here. So Z1 is -2 plus 3I. Okay, you don't have to put the parentheses, but it's better you do it. But for this one, it's very important. So 2 minus I. So if you don't put parentheses here, so this is very, very important. Very, very important. If you don't use the parentheses here, so probably most likely you will get a bad result, wrong result. So let's do this one here. Let's combine the reals with reals. As I see here, they will cancel out, and 3I and minus I, so it will be 3I minus I. So you can do like, it's 2I, definitely. But if you have difficulty here, you can do like the common factor, مشترك عامل. So you can do this times 2, which is 2I. Anyway, so for this one, okay, -2 plus 3I. Let's open the parentheses now. This is minus, so it will be -2, and this is minus, it will be plus. So we have this one. Now, what is this equal to? Or I divided by, okay, -2, combine the reals, -4. Combine the imaginary parts, we have 4I. Okay, we will write it this form. So we are not done yet. We are just halfway to our target. Now, one thing we can do here is we can try to simplify it. So how can we simplify? You see that here 4, you can write here 4 minus 1 plus I. You can factor it because this is a common factor here, 4, 4. So you will end up with this I divided by -1 plus I. So now our question comes to here, this I, what is I over -1 plus I? So in order to write it, okay, change this one to a standard form. You write okay, you multiply it with conjugate. So its conjugate is this one. You see it's plus. So here it will be minus. So write the same thing in order to keep the value same. So the mathematical value will not be same if you don't write one of these. Anyway, it's I minus I, and this will be minus I squared divided by -1 squared minus I squared. This will be minus I minus -1 divided by 1 minus -1. So we will end up with minus I plus 1 divided by 2. Then you can write it as okay, you can change their places here. Plus 1 minus 1 here, minus I. So separate them. So here we got the standard form. Okay, let's do this exercise. So find the conjugate of 3 minus I divided by minus 1 plus negative 1 plus 2I. And it says hint, write the complex number standard form. Okay, first, let's write it in standard form. So let's remember what is conjugate. So if A plus BI and A minus BI, they are conjugate of each other. Okay, what does this mean? So 3, the conjugate of this is with plus. And if it is plus, this has to be negative. This has to be minus, okay? So plus, minus, minus, plus. Okay. Now the first thing we have to do is this then. Okay, so we have to write it in standard form. Okay, standard form is, as you know, this is standard form. Okay, 3 minus I divided by minus 1 plus 2I. Then you you multiply the denominator with the conjugate and do the same thing to the numerator. Multiply them. This is automatically, since we have plus and minus issue, this is automatically minus 1 squared plus 2I squared minus, sorry, this is minus y squared. And if you do this multiplication, you will get minus 3, negative 3, and then negative 6I plus I, and then plus 2I squared. And here negative 3, and then combine the i's here. So this, don't combine this one. This is minus 1. So this is minus 5I minus 2 because of this. You can say plus 2 times minus 1. And here from 1, and here it's a minus 4 times minus 1. It's because of the I squared. Now it will be 5 here, and this part will be negative 2, negative 3, it's negative 5. So we end up with, okay, 5 is a common factor, it seems. And then minus 1 minus I. So this is the standard form of it. Now it's asking the conjugate. So we can write here conjugate now of 3 minus I over negative 1 plus 2I is, okay, it's equal to that one, not the conjugate, but the fraction itself is equal to this one. So what's the conjugate of this? It's minus 1 plus I. Because this fraction is equal to this number, and the conjugate of this number is negative 1 plus I.